Good morning. It is Wednesday, May 13th, and this morning I'm going to attempt a lab demo in my kitchen for you. So the first thing that I want to point out is that the purpose of this is going to be, by the end of this lesson, you should be able to guess which indicator I used in this lab demonstration. So I'm calling it the Mystery Indicator Lab Demo. And so you'll be able to play this video back, and I'm also going to tell you step by step what I'm adding so that you can try to figure out, based on your observations, which indicator I used. So the first thing that I have in my graduated cylinder is some sodium hydroxide, NaOH. This is a 0.1 molar solution, and I have about 100 milliliters of it. And what I'm going to add to my graduated cylinder is about 350 milliliters of water. And so in this container, I just have some water. All right, so I have about 400 total milliliters of solution in here, 100 milliliters of sodium hydroxide, and 350 milliliters of water. I'm going to go ahead and add my mystery indicator. And you can note any sort of color changes. I'm also going to add an Alka-Seltzer tablet. And as we're noting any color changes, and as that tablet starts to cause a reaction and rise in the cylinder, I'm going to top off my reaction with about 10 milliliters of vinegar. Awesome. Okay, so again, you can replay that reaction as many times as you need to. And we're gonna shift over to this week's lesson. Okay, so part one of this week's lesson is to make some observations about the reaction in the graduated cylinder, which again, I'm calling the mystery indicator. And I'm going to provide you with some information this week in this lesson to make an educated guess as to which indicator I used from a list that we're going to discuss. This will be your first quiz question this week. Is worth about 7 points to really tell me with detail, using evidence and reasoning, which indicator you think I used in that demonstration. Part two is we have just 2 more topics left to discuss on acids and bases, which is what pH really is, and we'll go into some more details about indicators. This is the last week we'll spend on acids and bases. And then I added a virtual activity this week. A lot of you kind of told me that you were a little bit interested in reactions in nature and what acid rain and acid precipitation and ocean acidification were all about. So I found it's not really a virtual lab. Last week's was definitely a lab. This is really more of an activity, and that will be the last thing that you need to complete. Choice activities are going to be minimal this week because we have 3 parts to the lesson. So again, when you take your quiz this week, the first question you will see is which indicator do you think I used? with that acid-base rainbow mystery indicator demo that I just showed you. Okay, so we're gonna start off by talking about indicators this week. And there are some reference table tricks for you if you ever need it. Tables K and L are lists of common acids and bases. So if you're ever doing a titration question or they give you the substance name and you're not sure what pH range that substance might be in, everything on table K is an acid and everything on table L is a base. Table M is what we're going to go through today, are common acid-base indicators. So they give you the name of the indicator, and then this part we're going to need to explain a little bit, the approximate pH range for the color change that you'd see using that indicator, and then what the color change actually is. If you have a set of colored pencils, I would pause the video and I would go grab that set of colored pencils, and I can show you a really cool trick for how to answer questions about indicators. Okay, so we've already discussed 3 types of indicators. Litmus was an indicator that was used to define acids and bases. So litmus in an acidic solution is red, but in a basic solution is blue. So you saw some questions about, what type of substance changes red litmus to blue. If it turns to blue, that's a base. If it turns from blue to red, that's an acid. Phenolphthalein is an indicator that we used in the titration lab, and phenolphthalein is an indicator that's colorless until the pH changed to 8. So it was a good one to represent the neutralization point in a titration, because once it changed from colorless to pink or pink to colorless, you knew that it was about neutralized, about a pH of 7 to 8. Universal indicator was used in our very first lab activity, and I have included that color scale here. I really like universal indicator because it has so many different color spectrums. So you can really accurately identify the pH level based on the color. As you see on table M over here, universal indicator is not a Regents indicator. However, it is one of my favorites just because it is so accurate. So I have a series of questions for you to consider using table M. So the first thing I want to figure out here is, what color would a solution with a pH of 2.6, so an acidic solution, be in Brom-Kressel green? Brom-Kressel green is not an indicator we use very often. However, Brom-Kressel green is an indicator that changes from yellow to blue. So just like litmus changes from red to blue or blue to red, Brom-Kressel green won't show a red color. So how we can predict this is if you think of these pH numbers in the middle as a spectrum, and I break it up into thirds. Brom-Kressel green is going to be yellow. So if I had colored pencils right now and access to that on my tablet, I would color this little piece yellow. Anything from 0 to 3.8 is going to be yellow in this indicator. In this small window, we're going to see an intermediate color between yellow and blue. But beyond a pH of 5.4, Brom-Kressel green is going to be blue. So you want to think, what would the transition color be between yellow to blue? And in this 3.8 to 5.4 range, I would see green, because yellow and blue make green. So to answer this question, if the pH is 2.6, that's below that range, so Brom-Kressel green would be yellow. Let's try another one. This time I want you to name 2 indicators that would be red in an acidic solution. So the first thing you need to know is that acids have pH levels of less than 7, because 7 is neutral. Next, you want to look at any indicators that would be red at all. I see methyl orange is red. I see litmus is capable of being red. And then let's not forget about our good friend universal indicator can also be red. So all of these, methyl orange would be red lower than 3.1, so that counts as being an acid. Litmus is red below 4.5, so that looks like that could satisfy that question. Universal indicator is red in a pH of 0 to 1, so any of those three could answer that question. So again, with the colored pencils, if I'm looking at methyl orange and litmus, I would maybe color this block red. Think about what the intermediate color would be for both of them. And then beyond in methyl orange, higher than 4.4, that would be yellow. And in litmus, higher than 8.3 would be blue. So what's the intermediate color from red to yellow? Well, it's right here in the name. Between 3.1 and 4.4, I would see orange in methyl orange. But in litmus, between 4.5 and 8.3, the intermediate color from red to blue, I would see purple. And litmus is very similar to universal indicator, except for that little piece, because in universal indicator, you see purple way over here, and in litmus, purple is going to be more in the neutral range. Next question, what color is bromthymol blue in a pH of 7? So bromthymol blue is this one here. Bromthymol blue is also a really good indicator that I like to use for titrations, because look at the transition color period here. Between 6 and 7.6 is where you would show that intermediate color. So under a pH of 6, all we know is that bromthymol blue is yellow. So bromthymol blue is yellow if it's acidic, below 6. Above 7.6, above neutral, when it's a base, it's blue. But it's got a really good neutral range. 6 to 7.6 is about as neutral as it gets. The intermediate color between yellow to blue would be green. So what color is bromthymol blue in a pH of 7? It would be green. All right, last question about pH before we move on, or indicators. Which indicator is green in a pH of 8.9? Notice none of these turn to green. So you need to figure out which ones could possibly turn green at that intermediate color. So between bromthymol blue, yellow to blue, bromcresol green, yellow to blue, and thymol blue, yellow to blue, which one would be green if the pH was 8.9? Bromthymol blue would be blue in that pH level, so we're going to get rid of that choice. What about bromcresol green? What color would bromcresol green be above 5.4? It would be blue, so get rid of that. But thymol blue, in a pH of 8.9, it's yellow before it hits 8, and it's blue after 9.6, which would mean that in this range, which 8.9 falls into, it would be green. So thymol blue would be our answer. If you're using universal, I would also have accepted that, because in a pH of about 8 to 9, it's a greenish blue. Okay, moving on from indicators, I just want to remind you of the things that I added in the daily discovery. So what you might want to do is rewatch that the demo and think about what would this pH be and what color did it turn when I added this indicator. When I added the Alka-Seltzer tablet, what happened to the pH and the color? And then lastly, when I added vinegar, which is just acetic acid, what happened to the pH and what happened to the color? So you can use your indicator table M and try to match up colors to pHs as pieces of evidence. Okay, last little piece of new information. We've talked about the pH scale for the last almost 4 weeks now, and we've never really defined it. So actually, the truth is that nobody really knows where the term pH came from, but it makes a lot of sense to think of it as parts hydrogen, pH. So the pH measures the concentration of H+ ions in a solution. When we see that term H+, we always assume acid. When we see OH-, that's when we started to consider bases. So the pH scale, as we know it, represents what's called a logarithmic increase or decrease in H+. And these brackets around the H+ stand for concentration. So it's kind of a shortcut to say concentration of H+ in a solution. So what do I mean by a logarithmic increase or decrease in H+? Let's say I have a solution that is neutral. It has a pH of 7. It has an H+ ion concentration of 10 to the negative 7. There are complicated calculations that go into this, but I'm going to save that for those of you who are braving AP Chem next year. We know that if we go down on the pH scale, we are getting more acidic, and if we go up on the pH scale, we're getting more basic. But what does that mean in terms of H+ ion concentrations? If I'm getting more acidic, I have more H+ ions. Therefore, the concentration of H+ increases the more acidic I get. If I get more basic or alkaline, I have less H+ ions and more OH- ions. So if I go from 7 to, let's say, 12, I decrease the amount of H+ in a solution. Each number on the pH scale represents what we call a 10-fold increase or decrease in H+ ion concentration. So for example, if I have a pH of 10 and I increase the H+ ion concentration 10-fold, I move 1 to the left on the pH scale. So I go from a pH of 7 to 6. If I increase it 100-fold, I go 2 spaces. The pH is now 5. And if I increase it 1,000-fold, I go 3 down on the pH scale, and the pH goes down to 4. Again, that's increasing the H+ ion concentration. But what if I start at 7 and I want to decrease the H+ ion concentration? Let's say I decrease the H+ ion concentration 100-fold. That way, I'm going to go this way 2 ticks. 10, 100, my new pH is 9. For those of you moving on to AP Chem and College Chem in the future, I just want to mention that in addition to a pH scale, there's also something called a pOH scale, which measures how many hydroxide ions are in a solution. We're not going to tackle this week, but you would kind of look at it the same way. It's the opposite of the pH scale. So as you increase the pH, you increase the pOH. And as you decrease the pH, you decrease the pOH. Again, if you're not going on to AP Chem, you can just sort of disregard that. All right, so let's do a couple of practice problems. This is a typical question. Before a base, such as agricultural lime, calcium hydroxide, was added to a field, the pH was 5. After the lime was added, the soil underwent a 100-fold decrease in H+ or hydronium ions in concentration. What is the new pH of the soil? Okay, a couple clues here. First of all, we're starting at 5. It tells me that I'm adding base. I also know CaOH2 is a base. And if I'm adding that, I should be increasing the pH more towards the alkaline end of the scale. But what this tells me is that it undergoes a 100-fold decrease in H+. Remember, this way means more H+, this way means less H+. So if I start at 5 and I decrease the amount of H+, I'm going to go this way 2 times, because 6 would be a 10-fold decrease in H+, and 7 would be a 100-fold decrease in H+ ions. So my new pH would be 7. What color would bromthymol blue be at this new pH level? Well, we would use table M. Bromthymol blue goes from yellow to blue, and in between 6 and 7.6, it's the transition color green. So at 7, my new pH level, bromthymol blue, would turn green. Next question, a truck carrying nitric acid overturned and spilled its contents, allowing acid to run off into a nearby pond. The pH of the pond was 8 before the spill. So I'm going to circle 8 on my pH scale. Before this spill of acid, the pH was 8. After the spill, the pH is now 1,000 times more acidic. What is the new pH of the pond? So 1,000 times means 3 jumps on the pH scale, 10, 100, 1,000. More acidic means I'm going to go to the left. So 10-fold, 100-fold, 1,000 times more acidic than 8 would be 5. What color would bromthymol blue be in this new pH? Well, below a pH of 6, bromthymol blue is yellow. All right, the last thing that I'm going to have you complete today is a virtual activity. This is not really a virtual lab. I am going to take you there now by sharing my screen to Schoology. When you click on the Acid Rain virtual activity, it will take you to a screen that looks like this. You have to read what's on the left. I promise you, you have to use this drop-down menu, because not only does it tell you what acid rain is and how it forms, the procedure is all the way down at the bottom. So it tells you to start clicking on some test tubes, entering the state's pH value based on the test tube that you click on. So Arizona, AZ, has a pH of 5. You click on, here it is, Arizona, and a pH of 5 would color it in this way. So you're going to create a map of the United States based on average pH of the rain. When all is said and done, you're then going to kind of superimpose a map of a pollutant to try to make a connection between the pH of the rainfall and the amount of pollution. The last one, number 6, says complete the journal questions, which you'll find in here. You are welcome to answer them in here, but I have copied and pasted these questions, and they are actually part of your quiz. So when you go to your quiz this week, those exact questions will be what you're answering in your quiz. So you might want this open while you take your quiz so that you can answer those questions. All right, last thing to explain is your choice activities. I'll be available today on Zoom. If you want to continue doing review book questions, I didn't assign you very many this week since you have 3 parts to this lesson. If you want to complete topic 10, page 189 to 191, you can do numbers 12 to 17, 37, 38, 39, and 42 through 44. I'll put an answer key up so you can either check them yourself or you can join me on Zoom today at 2 o'clock. Second choice is in the activities folder, I put an article. It's not really an article, but it's called Why Are Acids and Bases Dangerous? I had a request to learn a little bit more about acids and bases and why they're harmful to the body. So that is an option. And then choice 3 requires you to send a photo or a video. I want you to be clear in the email if you don't want me featuring it on the Instagram page. So you could send me a photo or a video of a socially distant or family nature walk. Remember, you need to like wear masks out and do all that stuff and stay 6 feet apart unless you're part of the same family. You can send me a photo or a video of you helping a family member with a chore or their schoolwork. You can send a photo or video of your pet doing your homework. Or you can create a TikTok that promotes a science or technology course that you think other students should take before they graduate high school at PHS. So hopefully there's something in there that you're interested in. Check out the Daily Discovery. Go through this video lesson, pH and indicators, and complete the activity on acid rain. The quiz, again, was due just like always by Sunday. And I just want a special note out there that interim reports are going to be due in the upcoming week. So if you have not completed 65% of my work, you will be getting an F, meaning fail. It's not too late. So contact me and let me know if you need to do some makeup work. All right, that does it for this week. And I will be around for questions or a Zoom today at 2 o'clock.